Here we come to A-Level Physics 2006 question 6. So here we have two situations. Number one, we have a pendulum motion. So that's the pendulum, the bob will go back and forth, back and forth, back and forth. Okay, so it will follow this path, swing back and forth. Situation 2, we would have a bob which is set into a conical pendulum, so it will perform circular motion. So the bob will go like this in a horizontal circle. So it will not go up and down, it will just go on a horizontal plane. So in this two situations, we take a moment when the bob is at the extreme point at here. Okay, so it is asked about at this position we in the string we have T1 and T2 respectively. So we would like to find the expression for T1 and T2. First of all, I've already done it for you. We have draw the free body diagram. There are forces acting on the bob. We have T1 and mg on the situation 1. And also in situation 2, we have T2 and mg acting on the bob. So it seems similar. However, there is a crucial difference. And very importantly, you are always asked to consider, when you try to resolve the force, you must consider one thing, that is, which direction you should resolve the force into. Like in situation 1, you ask yourself one crucial question, that is, now the bob is here. In the next second, where will it go? What would be the direction of motion in this moment? So we know that the bob will go in that direction. The acceleration and the subsequent motion is in that direction, an incline. However, in the second situation, because the bob just go along a horizontal circle, so basically the bob at this moment, the bob will go to the right hand side. So the acceleration is horizontally moving to the right hand side. It will not go up, it will not go down. The acceleration is completely horizontal. Therefore, when we try to resolve the force, we have to see which force acting on the bob is not along the direction of motion or not perpendicular to the direction of motion. Now let me give an example. On left hand side, we have T1 and mg. And we know that the acceleration is actually along this direction. Okay, the acceleration is along this direction. So basically, you can see that T1, it is actually perpendicular to the acceleration. So we do not need to resolve this force. However, mg and the acceleration is not perpendicular nor parallel. So in order to do the calculation, we need to resolve this force mg. We need to resolve it. So this is what we are going to do. We will resolve mg into mg cosine theta, which is perpendicular to the acceleration, and mg sine theta, which is parallel to the acceleration. However, in situation 2, things are a little bit different, because this time the acceleration is completely horizontal. Okay, so the acceleration will be along this direction. Here you can see mg pointing downwards. Actually, it is perpendicular to the direction of acceleration. So it needs not to be resolved. We can just leave it like that because this force is perpendicular to the motion. However, if we look at T2, T2 and acceleration, they are not completely perpendicular nor parallel. So in this case, we need to resolve T2 into its component. So we'll resolve T2 into vertical component, which is given by T2 cosine theta and T2 sine theta. So you can see, based on different motion, by looking at different direction of motion, we have to decide which force to be resolved. Our aim is to resolve the force so that all the force will be either parallel to the motion or perpendicular to motion, but nothing else. So in this situation, we resolve the mg so that all the components will be either parallel or perpendicular to the acceleration. And in this situation, we try to resolve the T2 so that all the components will be either parallel and perpendicular to the acceleration. So now we are trying to make some equation. So let's look at T1 on the left hand side. Because we have resolved the mg, so we can write down T1 equals mg cosine theta by considering this and this. Of course, you can consider this direction and write down mg sine theta would give rise to the acceleration, but that is not useful in this situation. And on the right hand side, this horizontal circular motion, we can consider the vertical line. Okay, we have an upward T2 cosine theta, we have a downward mg. Also, we have a horizontal T2 sine theta, which will give rise to acceleration. So we can write down T2 cosine theta equals mg. Of course, you can also write down T2 sine theta is equals to ma, which is not useful in this question. Now, so you can see that comparing T1 equals mg cosine theta and T2 cosine theta equals mg, we would get what? We would get T2 is equals to mg divided by cosine theta. So therefore, the answer here for T1, we will have mg cosine theta, and for T2, we will have mg divided by cosine theta. And the difference, again, let me emphasize again, is because the difference in different situations, the motions are different. The subsequent acceleration and the motions are different in these two cases. So you have to decide which force, whether mg should be resolved or T1 should be resolved. Okay, mg should be resolved or T2 should be resolved.